In this video, we continue with the Theorem of Pythagoras. Example 1. Calculate the length of GH. Here we are given 3 different side lengths, and we are also given that the angle at F is a right angle. Therefore, there are 2 right-angled triangles in which we can use the Theorem of Pythagoras. Firstly, we can work in triangle EFG, and then we can also work in triangle EFH. But unfortunately, side GH is not a side of either of these 2 triangles. The triangle in which it does lie does not have a 90-degree angle. This means we can't use the Theorem of Pythagoras in this triangle. What we can do is we can work in the small right-angled triangle and determine the side FG, and then we can work in the bigger right-angled triangle and calculate side FH. Subtracting these 2 lengths will give you the length of GH. So, starting in triangle EFG, we want to determine one of the shorter sides. Therefore, to determine side FG square, we're going to start with the hypotenuse square and subtract the other shorter side square. Remember to also supply your reason. This gives you a value of 400 for FG squared, so taking the square root will give you side FG as 20. Next, we can work in the bigger triangle, triangle EFH. And once again, we want to calculate one of the shorter sides, in this case, FH. So, taking the hypotenuse of this triangle and squaring that, we're going to subtract the shorter side squared. This will give us a value of 784, and the square root of this will give us FH as 28. So, to finally determine the length of GH, we're going to take the longest side, FH, and subtract the shorter one, FG. This is 28 minus 20, which means that GH is 8. In the next example, you will see that we also need our knowledge from geometry of 2D shapes. We are given that IJKL is a rhombus with JK10, IM6, and MN3. The first question is to calculate the length of JM. I'm going to start off with the given facts. IJKL is a rhombus, and we know that that means all the side lengths are the same. So, not only is JK 10, but also LK and IL and IJ. This is because they are all sides of a rhombus. From this sketch, we also know that the angles at M are 90 degrees. This means we now have a right-angled triangle in which we can calculate JM. So in this triangle, we want to once again determine one of the shorter sides, JM, and therefore JM squared will be equal to our hypotenuse squared minus the other shorter side squared. And still my reason here is Pythagoras. 100 minus 36 is 64. And to now determine the value of JM, we need to take the square root, so JM is 8. Question B. Calculate the length of KLN. Earlier we already mentioned that KL is 10 because it's one of the sides of the rhombus. And IL is also 10, and that means that ML is 4, so that added to the 6, we get that 10. This means that in our bottom right-angled triangle, we can determine the value of Ln. Ln is the hypotenuse, so Ln squared will be the sum of the squares of the other two sides. Adding this up will give me a total of 25, which means that Ln is the square root of that, and that is 5. So to finally get the length of KLN, we already mentioned that KL is 10, and now we need to add the length of Ln, which is 5, so KLN is 15.